Hello friends, I am Ajit Kumar Jazing Mana Deshmukh, working as Assistant Professor in Mechanical Engineering Department of Gyan Shri Institute of Engineering and Technology, Satara. Here I am presenting standards for energy management in International FDP on environment and sustainability. This slide shows the information about video presenting in Week 1 and Week 2 presenting in International FDP on environment and sustainability. After learning through video, students will appraise environment and sustainability standards related with wind turbines, categorize wind turbines in view of energy efficiency. 3. Relate carbon footprint with action of individual, a family, an organization or even an entire nation. This slide shows the pictorial view of ISO standards related with energy and energy management. Let's talk about ISO/TC 265, carbon dioxide capture, transportation, and geological storage. Carbon capture and storage. ISO has published a number of standards that facilitate the use of this innovative technology, which consists of extracting carbon dioxide, CO2, emissions from large stationary sources and injecting them into a geologic storage formation for safe and secure disposal. Let's talk about energy management. ISO/TC 301, energy management and energy savings. In addition to ISO 50001 on energy management systems, see box overleaf, our most widely used energy-related standard. ISO has developed standards on energy performance indicators, the measurement, analysis and verification of energy performance, as well as methodologies for the calculation of energy savings in projects, organizations and regions. Let's talk about environmental management. ISO/TC 207, environmental management alongside ISO 14001 for environmental management, ISO 14064 on the quantification and reporting of greenhouse gases, and ISO 14025 on environmental labels and declarations are just some of the many standards that help organizations reduce their environmental impact through smarter energy usage. ISO 50001 for energy management. ISO 50001 to 2018, energy management systems, requirements with guidance for use, is one of ISO's most widely used standards, with over 20,000 certifications issued in 2016 alone, up 70% from 2015, not to mention the organizations that use it without getting certified. It provides organizations with a recognized framework for developing an effective energy management system. Like other ISO management system standards, ISO 50001 follows the Plan Do Check Act process for continual improvement. ISO/TC 163, thermal performance and energy use in the built environment. Energy consumption in buildings accounts for over 20% of total primary energy use worldwide, and up to 40% in developed economies such as the United States and the EU too, and it is on the rise. ISO has a number of standards that help make buildings more energy efficient, covering everything from the design of the whole building to its individual parts. This includes the ISO 52000 family of standards, which takes a holistic approach to improving the energy performance of buildings. It contains a comprehensive method of assessing energy performance as the total primary energy used for heating, cooling, lighting, ventilation, domestic hot water of buildings, thus supporting new technologies and approaches to building design and management. Renewables, ISO/TC 180, solar energy. ISO has published over 50 standards for solar energy systems and biofuels, namely standards for performance ratings and test methods, solar heating, solar panels and solid biofuels. Future technical work will cover solar thermal collectors and the safety of solid biofuel pellets. This slide shows greenhouse gases. This slide shows greenhouse gas effect. Excessive heat retention could lead to massive changes in environment. The temperature of the planet would be similar to conditions experienced on the Moon. It's true that wind power isn't a zero-emission energy source. Greenhouse gas emissions are produced when wind turbines are manufactured, built, maintained and decommissioned. But the life cycle greenhouse gas emissions from solar, wind, and nuclear technologies are considerably lower and less variable than emissions from technologies powered by combustion-based natural gas and coal, says the NREL. To be more exact, wind energy produces around 11 grams of carbon dioxide per kilowatt-hour of electricity generated, Garvin A. Heath, a senior scientist at NREL, and colleagues concluded after reviewing the scientific literature. That's compared with about 980 grams CO2/kWh for coal and roughly 465 grams CO2/kWh for natural gas, Heath found. In other words, coal's carbon footprint is almost 90 times larger than that of wind. The footprint of natural gas is more than 40 times larger. Like Heath, Rhodes found that wind power had one of the smallest carbon footprints at 14 grams CO2/kWh, second only to nuclear power. That's a carbon footprint over 11 times smaller than that of coal with carbon capture technology. This slide shows type of energy and carbon footprint. How we can achieve the sustainability in energy. There are 7 steps to achieve the sustainability in energy. Policy matters. Planning matters. Markets matter. Finance matters. Mindset matters. Cooperation matters. Politics matters. These are some standards of energy and energy management. Thank you.